learning has revolutionized artificial intelligence, enabling groundbreaking advancements in image recognition, natural language processing, and robotics. These technologies are now seamlessly integrated into our daily lives, from voice assistants to autonomous vehicles. At the heart of this revolution lie deep learning frameworks, powerful tools that simplify the development of complex neural networks. These frameworks provide the necessary infrastructure to build, train, and deploy sophisticated models efficiently. Among the leading contenders in this space are Keras, TensorFlow, and PyTorch. Each of these frameworks has carved out a niche, offering unique features and capabilities that cater to different needs and preferences. Each framework brings unique strengths, making the choice of the right tool critical for developers and researchers. The decision often depends on factors such as ease of use, flexibility, and community support. Imagine building a skyscraper. You wouldn't lay every brick by hand. Similarly, deep learning frameworks provide the scaffolding and tools to streamline the process of building and training neural networks, saving time and effort. These frameworks offer pre-built components and libraries, allowing developers to focus on fine-tuning and innovation rather than reinventing the wheel. This accelerates the development cycle and enhances productivity. In this essay, we'll explore Keras, TensorFlow, and PyTorch, delving into their features, performance, and communities. We'll examine how each framework supports different stages of the development process. By the end, you'll be equipped to choose the framework that best aligns with your skills and project requirements, ensuring you can leverage the full potential of deep learning in your work. Keras stands out for its simplicity in the deep learning world, making it a favorite among developers. Built with user-friendliness in mind, Keras acts as a high-level API, abstracting much of the complexity of building neural networks. Think of it as the easy-to-use interface for deep learning, allowing quick prototyping and experimentation. Building a neural network in Keras is like assembling Lego blocks. You can stack layers, define input and output shapes, and compile your model with a few lines of code. This simplicity makes Keras ideal for rapid prototyping, allowing quick iteration without intricate configurations. Keras's extensive documentation and examples make it easy for newcomers to get started. The community support is also robust, providing a wealth of resources. However, Keras's simplicity might not offer the same level of control as TensorFlow and PyTorch. Advanced users might find it limiting for highly customized models. Despite this, Keras remains a powerful tool for those who prioritize ease of use and rapid development. Its design philosophy centers around being user-friendly, making it accessible to a wide range of developers, from beginners to experts. Developed by Google, TensorFlow has become a cornerstone in the world of deep learning. TensorFlow is a titan in deep learning frameworks, offering unparalleled capabilities. Renowned for its power, scalability, and versatility, it stands out in the crowded field of machine learning tools. TensorFlow is the go-to choice for deploying machine learning models across various platforms, from mobile devices to large-scale servers. At its core, TensorFlow is a computational graph framework, which means it represents computations as interconnected nodes. This graph-based approach allows for efficient parallelization and optimization, making it highly effective. This efficiency is crucial for handling massive datasets and complex neural networks, which are common in modern AI applications. TensorFlow's architecture makes it suitable for both research and production environments, ensuring seamless scalability. TensorFlow scales seamlessly from research to production, streamlining the entire machine learning workflow. This streamlined workflow is essential for developers who need to move quickly from concept to deployment. Whether building a recommendation system to enhance user experience or training a self-driving car to navigate complex environments, TensorFlow provides the robust infrastructure needed to tackle ambitious projects and push the boundaries of technology. However, TensorFlow's immense power comes with increased complexity and a steeper learning curve, which can be challenging. For those seeking to harness deep learning's full potential, mastering TensorFlow is a worthwhile endeavor. TensorFlow remains an industry-leading choice, trusted by top-tier companies and researchers worldwide. Emerging from Facebook's research labs, PyTorch has gained popularity for its flexibility and dynamic computation. Its intuitive Pythonic interface and dynamic computation graphs make it a favorite for experimentation and cutting-edge models. Unlike TensorFlow's static graphs, PyTorch constructs graphs on the fly, allowing greater flexibility during runtime. This dynamic nature suits tasks like natural language processing and speech recognition, empowering researchers to experiment with novel architectures. PyTorch's strong GPU support and integration with Python libraries make it popular for both research and production. Performance comparison: TensorFlow versus PyTorch versus Keras. Performance is paramount in deep learning frameworks, impacting productivity and problem-solving feasibility. TensorFlow, with its optimized computational graph and distributed computing support, excels in large-scale deployments. PyTorch, known for dynamic computation and efficient memory management, excels in flexibility and rapid prototyping. Keras, as a high-level API, relies on TensorFlow or Theano for computation, offering ease of use and rapid prototyping. While TensorFlow and PyTorch may outperform Keras in benchmarks, Keras's simplicity makes it a strong contender for practical applications. Each framework has its strengths, influenced by hardware, model architecture, and specific tasks. Usability and learning curve. Finding the right fit. Choosing the right framework depends on performance, usability, and learning curve. Keras offers a gentle learning curve and intuitive API, appealing to both beginners and experienced practitioners. TensorFlow presents a steeper learning curve due to its lower-level API and computational graph complexities. However, TensorFlow's comprehensive documentation and community support make it accessible. PyTorch balances power and usability with a dynamic computation and Pythonic interface. Its active community and resources contribute to its ease of adoption. Community support. Thriving ecosystems and resources. The success of open-source projects hinges on community strength. TensorFlow, backed by Google, boasts a massive and active community with extensive documentation and forums. PyTorch, despite being newer, has garnered a dedicated following, especially in research. Its intuitive API and GPU support make it a favorite for novel architectures. Keras benefits from a diverse community, ranging from beginners to experts, fostering a welcoming environment. Each framework's community contributes to its growth, support, and collaboration. Choosing the right framework. A use case perspective. The right framework depends on your use case, experience level, and project requirements. For beginners or those building prototypes, Keras offers an ideal starting point with its user-friendly API. Researchers pushing deep learning boundaries may prefer PyTorch for its flexibility and dynamic computation. For deploying models at scale and handling massive data sets, TensorFlow's power and maturity make it the industry-leading option. Each framework has its strengths, tailored to different needs and aspirations. The future of deep learning frameworks. As deep learning evolves, so do the frameworks powering it. We can expect advancements in hardware acceleration, automated machine learning, and support for emerging architectures. Custom hardware like Google's TPUs promises greater performance and efficiency. AutoML aims to automate aspects of the machine learning workflow, making it easier to build high-performing models. The field of deep learning is constantly evolving, with new architectures and techniques emerging. Frameworks that adapt to these advancements will continue to thrive. Conclusion: embracing the power of deep learning. The journey through Keras, TensorFlow, and PyTorch reveals a vibrant ecosystem of frameworks. Keras empowers beginners and rapid prototyping with its simplicity. TensorFlow excels in scalability and production environments. PyTorch attracts researchers with its flexibility and dynamic computation. Choosing the right framework is about finding the tool that aligns with your needs and aspirations. Embrace the power of deep learning. Explore the possibilities